Hello Jefferson. Today we will be solving problems using the Pythagorean theorem for three-dimensional figures like this shoebox. If we needed to find the diagonal of this shoebox, which from the inside is from the top corner to the bottom corner, we would be using the Pythagorean theorem 2 times. The first time we use the Pythagorean theorem, we would be needing to find the hypotenuse of the base. The base is the length times the width for the legs, and then the diagonal of the hypotenuse. Once you find the hypotenuse of the base, that hypotenuse actually becomes the leg for the second equation. The second equation would have the height as a leg, the diagonal of the bottom as a second leg, then the diagonal across the inside of the box is the hypotenuse. Now we are going to do a worked example of using the Pythagorean theorem for a three-dimensional figure. I am going to go back to my math interactive notebook, and in my table of contents, it is still under lesson 12.1. But now we are going to do the Pythagorean theorem . And this time it will be for a three-dimensional figure. And we're going to start on page 7. The Pythagorean theorem. These are for three-dimensional figures. We are going to do the example at the top of page 380, your turn. I'm going to read the question. Tina ordered a replacement part for her desk. It was shipped in a box that measures 4 inches by 4 inches by 14 inches. What is the greatest length in whole inches that the part could have been? All right, so we are going to solve this problem on page 7, and I am simply going to write the page number, page 380, and the question number, number 6, so that I don't have to recreate the figure in my notebook. I know that I'm going to have to do the Pythagorean theorem twice, so I'm going to write that twice in my notebook. I'm going to do my work on, split it into 2 columns. So we have a squared plus b squared equals c squared. A squared plus b squared is equal to c squared. For the first equation, I need to find the base. Okay, the base of this figure is 4 by 14. So that is 4 squared plus 14 squared is equal to c squared. And once again, that is the diagonal of the base. 4 squared is 16. 14 squared is 196. And that is going to equal c squared. 16 plus 196 is 212 is equal to c squared. Now at this point, I do not need to use my calculator to find the radical because it is already squared here. I already have my answer. I don't have to square it again in this equation. But this now becomes the leg, so I'm going to put it in this equation over here. The height for my figure is 4 inches, so it is 4 squared plus 212, once again, because this is square and this is square. So if I do not take the radical of this, I don't have to square it here. It's just doing this the opposite. And this is going to equal c squared. So 16 squared plus, just kidding, 16, 4 squared is 16, plus 212 is equal to c squared. 16 plus 212 is 228 is equal to c squared. Now I'm going to take the radical of 228, and the answer is 15.099668887, and then it is going to keep going. Now, how do I write my answer? I'm going to reread my question. The question says, what is the greatest length in whole inches that the part could have been? So I'm going to have to round this to the nearest whole number. Therefore, my answer is 15. It is very important when you are taking the Common Core assessment that you follow directions. If it tells you to round to the nearest whole number, please do that. If it tells you to round to the tenths, like yesterday's exercises, please do that. If it doesn't tell you to round, please use your best judgment, but round accurately. Thank you.